Hi everybody. I just finished hooking up my variable frequency drive to the Wells Index mill, and I had been thinking about that I probably wanted to do a little video just about variable frequency drives and share some of the information that I had culled by going on various different websites and reading a lot of different threads and different forums, and I thought maybe it might be helpful to somebody who's considering a variable frequency drive for their shop equipment, whether it be a lathe or a mill that they picked up and has a three-phase motor, which was common in a lot of commercial applications or industrial applications. And most households do not have three-phase power. And three-phase power is common in many commercial and industrial areas, but it's not common in households unless your house happens to be in a commercially developed area. So what are you going to do if you get a lathe that's got a three-phase motor on it? Well, you can change the motor out, and sometimes you might want to do that. It might be more cost effective to do that. Maybe you're gonna only run that motor at one speed and do all of your speed changes with the gearboxes or change gears on the lathe. Well, then speed control might not be an issue, and so if the motor is not so constructed that it's kind of specialized as far as the mounting goes, then it might be just easier to just change it over. But let's say you want to use the three-phase motor that came with the machine, or let's say you have another reason why you want to use the three-phase motor with a variable frequency drive, and I'll get to that in a moment. But first, let's talk about what your options are if you need three-phase power and you don't have three-phase power coming into your shop. Well, you're going to need to convert it. You're going to need some type of a converter. So first, let's take a moment to talk about electricity. Here in the US, the electricity that comes into our homes is basically two-phase. You don't hear it referred to as two-phase, but there are actually two phases. All right, so what's coming in from the outside is two-phase power. And what's happening is, inside where these big cables, the service entry cable comes in, there are three big thick wires that come in and are supplying all of the power to the house. And what happens is, one of these three wires is going to be the neutral wire. One of these wires is going to be one of the phases and be designated as L1. And the other wire is going to be the other phase, the second phase, and designated as L2. And what happens is, the way that the breaker panel is designed is that the way that the mounts are for these circuit breakers, every other slot is going to be the other phase. So in other words, the phases each slot, the phase would be L1, L2, L1, L2, L1, going all the way down. So when you have a single pole breaker, that single pole breaker takes up one slot. It's only seeing one phase, and then the return path for the power is the neutral. A double pole breaker, because it's twice as wide, is going to take up two slots right next to each other. So that double pole breaker is going to be across L1 and L2. So if you only need a 120 volt circuit to run, say, your general purpose lighting and electrical outlets and the majority of the things in your home, you only need a 120 volt circuit. You're going to use a single pole breaker, and that single pole breaker is only going to be across one of the phases, and then the neutral is going to be your return, because your power goes out, does the work, and it has to come back. It has to be a complete circuit. If you got a 220 volt device, then you're going to use a double pole breaker, and the double pole breaker is going to be connected to L1 and L2. And what you're going to get is you're going to get double that 120 volts we just talked about, or 240. And you may hear that referred to as 220. There's there's going to be a discrepancy, and actually, depending on where you are located geographically, you're going to see differences. If you go to a friend's house and you measure, what's coming out of his outlet, chances are it's going to be a little bit different than when it comes out of your outlet, so on and so on. But the general gist I want to get across here is that we have L1 and L2 already present. So our problem is, with three-phase, we need L3. And L3, there isn't another wire that they just forgot to run here. It doesn't exist. You go out there to that telephone pole, to that transformer that's out there on the pole, that thing's not even sending out L3. So what are we going to do? Well, you could use a static phase converter. And what a static phase converter does is a static phase converter has components in them called capacitors. And a capacitor is an electrical device. I don't want to get too, I want to try and keep this low tech, so to speak. So let's just leave it at this. Static phase converter is going to use devices called capacitors to artificially create a third phase. Okay? So if you have a small three-phase motor and you only are running one single three-phase motor, you probably can get by perfectly fine with a static phase converter. And then of course also that means you're not interested in any speed control of that motor. All the motor's going to run at its rated speed and voltage, and you're going to do all of your speed changes with gearboxes or belt changes or something outside of the motor. So that's that. Okay. So then, well, what if you've got a big three-phase motor you want to run, or you want to run several three-phase motors? Well, now you're talking, you're going to need a rotary phase converter. And a rotary phase converter uses what's called a slave motor to artificially create the third phase. What ends up happening is they use the two phases to run the motor spins up, and when the motor's spinning, it actually generates the third phase. Three-phase converters can be pretty cost effective if you can get a hold of a three-phase motor and build your own phase converter. And I'm not even going to touch that subject, because I built my own. It worked for me because I only was powering a radial arm saw. Then when I tried to run the mill with it, I had a 1.5 horsepower slave motor. I had a 2 horsepower motor on the mill. It wasn't going to cut it. Couldn't do it. And that wasn't even under much of a load. Once I started cutting with the mill, it would have just been no good. So I decided I had to go either build a bigger rotary phase converter or go with a variable frequency drive. Getting back to the rotary phase converter. Possibly cheap to manufacture. Reliable, for the most part, pretty reliable. Drawbacks, I would say, not as energy efficient as a variable frequency drive. You've got the extra noise of that unit running, because you're going to have the motor, that motor runs. Some of the designs can get pretty elaborate. I mean, some of these designs involve having a dedicated motor that's responsible for just spinning up the other motor. Mine was small enough that I was able to use a capacitor and a potential relay as a start circuit, but now I'm getting, see, I said I wasn't going to get all technical, right? So, all right, let's ditch that. So we're going to move on now to the variable frequency drive, VFD for short. And what's so great about a VFD? Well, what's so great about a VFD is a VFD doesn't just take the two-phase or the regular 220 volt in and change it into three-phase 220 volt out. What a VFD does, modern VFDs, they have microprocessor control, they've got a whole bunch of extra circuitry going on in there, they've got inverter technology, there's a lot going on in there, but what it all ends up amounting to is this. You end up having more versatility and control of what's coming out of that thing and going to the machine. And I'll talk about that some more in a minute. So now I want to talk about, well, how expensive are VFDs? Well, the larger horsepower you need to run, the more expensive the VFD. That's rule number one. The quality of the VFD is going to be a big difference there, okay? You're going to find There are a lot of VFDs on, that auction site. The one we all love or hate, depending on how you feel about it. You're going to see a lot of VFDs selling very cheap on there, and many of them are a brand name that I can't even pronounce, but I think maybe it's Hwang, I don't know, but it's like H-U, I'll put the name up on the screen here because I'm never going to be able to say it correctly or spell it correctly in one shot. So let's talk about those for a minute. What's the problem with those? Depends on who you talk to. There's a big question as to the quality of workmanship in the construction. I don't think it's so much a design issue as it is just sloppy workmanship is what I'm hearing based on what I'm seeing online. There's a lot of guys that are buying these things dirt cheap, throwing them on drill presses and stuff in their shop and saying, hey, it's the greatest thing ever, they're so great, and they bought it dirt cheap so it doesn't cost them that much and they're happy with it. But then there's also quite a few people that are talking about seeing premature failures within the first so many months. And some of these guys are like, hey, the thing ran for 10 months, it was so cheap, we don't even care. We threw the thing out and got another one. They figured that they were doing enough work with the thing in the meantime that they were able to, I guess, pay for itself, so to speak. I wouldn't doubt if maybe their next purchase was a more expensive model from a better manufacturer. I shouldn't say better because, again, this is all just opinion based on what I've been reading out there. So there are more than one account out there of people who have had those drives fail and took them apart because they were interested to see if they could figure out what failed inside and just to see what the construction was. A lot of these guys had engineering and technical backgrounds, so when they opened it up they knew what they would be looking at. And some of these guys actually do repairs on these things for a living. And the majority of the people who have opened up those cheap drives have basically said what they saw inside there, they were surprised the thing worked as long as it did. Just shoddy workmanship, poor solder connections, just sloppy workmanship. And make a long story short, if you'd buy the dirt cheap Taiwan import drive, be prepared for the possibility of premature failure. Of course, that possibility looms with anything we buy these days. The second issue with those drives is many of those drives are not sold through dealers. They're sold basically, they're coming directly off the boat from China, and you're going to have longer delivery times. And the bigger problem is a lot of people are talking about the warranty is pretty much non-existent. Some people have said, they bought the drive failed. They tried to contact the company, they got no response from the company, or the company disappeared. Because it seems like as soon as one guy disappears, another guy pops up to sell them. So there's the question of whether or not you're going to have any, if it does fail prematurely, are you going to have any recourse? I would say, why don't you hedge your bet that you're not going to? Buy it with the understanding that you're taking a gamble. So that pretty much, I think, covers those drives. Oh, one last thing about any drive that you buy. Products that are made overseas, electrical products that are made overseas and then shipped to the United States, they're supposed to go through a certification process, like UL listing. Underwriter Laboratories is the UL listing, or there's another certification, I forgot what they call it. But basically what we're looking at here is we don't want anyone to get an electrical device into their house or business that's unsafe, that just is blatantly got something wrong with the design that makes it a fire hazard or a shock hazard or whatever. So we've got some safeguard built in. So you want to make sure it's got a UL listing. The reason why I mention this is because there's a story going around that there is a factory over in Asia churning out these VFDs, and that some of these VFDs are kind of going out a back door and circumventing the entire certification process, which costs money. Maybe they're factory seconds, maybe there's, maybe they just couldn't pass certain testing standards, I don't know. But there's a story that there are VFDs popping up here in the US, and other electrical components for that matter, devices, that have no certification whatsoever, no UL listing. So you got to be a little wary about that. You're talking about something that could burn your home or shop down. You're talking about something that could electrocute you or someone who works for you. So that's all I'll say. That's the last I'll say on those cheaper Asian imports. And I say cheaper Asian imports because the majority of the VFDs that I've seen out there are made in Asia, and a lot of them are darn good. So there are all different types of name brands of VFDs that are out there, and I think there's a U.S. manufacturer of a VFD that I looked into. I can't remember the name of it off the top of my head. If I think of it, I'll put it up here on the screen, and you can check them out if you want. So what did I end up going with? I ended up going with a TECO, T-E-C-O VFD, and they've got a pretty good reputation. There are distributors here in the United States selling those drives and backing those drives with full support and warranty support and technical support. And I'll say something about technical support. Technical support, if you can get it through one of these companies you buy your drive from, it's pretty good because the manuals, yeah, there's English in there, but it's English that was translated into English from Chinese by someone who's Chinese and doesn't speak English very well. So I found quite a few instances there where it was real obvious when I was reading it that, boy, I'll tell you, that's like somebody who's not really, hasn't mastered the English language any more than I have mastered Chinese, okay? So, I mean, that, let me say, I'm not knocking these guys, okay? What they wrote in there for English is a heck of a lot better than anything I could write in Chinese or any other language for that matter. So, but the thing is, when we're getting the thing in and we're trying to set it up and we're trying to go through the the whole process of wiring it, and there's any ambiguity in there, it's like, oh geez, So it's nice if you can call up and say, hey, so and so distributor, yeah, hey, I just got my VFD in from you guys, and I'm having a little trouble wiring it up. And you know what? They probably heard that question a million times before, and they're probably going to be very helpful. So a couple of companies that come to mind, and I've got no affiliation with these companies, so I got no reason to plug them, but I'm going to mention them anyways. One of the ones that pops up a lot, you might hear and comes up in conversations, is Factorymation. Not Factory Nation, Factorymation. So the second part of automation with factory in front of it, Factorymation. And then the second company I'm going to mention here is, I believe, Wolf Automation. Wolf Automation. So either one of those companies, I would say, if you're in the market for a VFD and you're able to spend a little more money, get something safe, reliable, with support, I would recommend either one of those two companies. And did I buy from them? To be honest, no. To be honest, I bought off of eBay. But what I did was I didn't buy that cheapie I was talking about. What I bought was I found a guy in Texas who doesn't normally sell VFDs, and for some reason he had 3 brand spanking new TECO units, and he only had the 3, and when he sold the first 2 and I didn't see anybody complaining about it, I snapped up the 3rd one. So what I ended up getting was a relatively expensive TECO unit, and a big part of the reason why mine ended up being so expensive is because mine's in a what's called a NEMA 4 enclosure, which is a special enclosure. Because if you just buy the drive, if you just buy the regular VFD, you take it out of the box, and you're gonna see that when you do your wiring hookup and everything to it, there's gonna be the ability for somebody to stick their fingers in there and zap themselves. And the point is, the drive needs to be then mounted in some type of an enclosure. So you've got to put the drive in an enclosure. Mine's already in an enclosure, and it's got a certain certification, which is why they call it the NEMA 4 classification of enclosure. So you pay a premium for that normally. But what I ended up doing was, basically I got the drive in a NEMA 4 enclosure for the price of what it typically sells for without the enclosure, but I probably have no warranty support because I didn't buy it through a distributor, an authorized distributor, and so I rolled the dice there, basically. I've already wired it up. It works perfectly fine, and I'm very happy with it, so I'm not worried. But just so you know, I just wanted to explain why I didn't buy from one of those two companies. Hey, that guy didn't have those. Like, if I went and looked today, I might not find anybody with that drive. So then I'd be like, well, I either buy the really cheapo and take my chances there, or I go to one of those two distributors I just mentioned and cut a deal there. Hi everybody. You know, I just finished hooking up my rotary phase converter.